we're going to look at probability. And probability in the last 4 exam papers has thrown out some general questions with 1 and 2 points as we got all the way through. With a probability question, you rarely get a 5 or a 6 pointer, purely because it's often bolted on the end of an activity where you've worked through, you've found out something else about it. And it's generally, if you look here, question F, and there's been 5 before, E, there's been 4 before, G. So as you can see, it's very honest. That's the first one ever. That's the first one. Generally, there are questions where there's been some prior information where you've worked through it, and the probability is normally, oh, what happens at the end? So let's have a look. I won't make them any bigger because the questions are quite straightforward. I don't need much worm to work out. It's non-calc. So 71% of the Earth's surface is covered in water. The rest of the Earth is land. What is the probability that a meteorite will crash into the Earth surface and will crash onto land? So quite straightforward. We've got the Earth. I'm not even going to attempt to draw the sea, but I'm going to do like that. So that's the sea. The blue's the sea. And we know that C is 71%. So the bits of the Earth have to be what makes it up to 100, because it's definitely going to hit the Earth. So it's 100% going to happen. It's just whether it hits the sea or the land. So the answer for that one is quite simply 29%. Non-calculator, so we take 100, take away 71 is 29. 1 mark. Scroll down. Marcus records a number of different holiday bookings made by his clients in 1 month. What is the probability that a client chosen at random is a new client that booked a flight and a holiday? Give your answer as a decimal. And we've got the calculator, so we can get our calculator up in here. So what is the probability that a client chosen at random, so out of all these clients, is a new client? So is a new client. So what is the probability of it being a new client? All of those are new. That booked a flight and a holiday. So we can clearly see here that our new client that goes on a flight and holiday is 19 people out of everybody, because it doesn't say it's a client that's chosen at random. So it doesn't say out of all the new clients. If it was out of all the new clients, we would just add these 3 numbers up. But it's out of everybody. So out of everybody, what is the probability that it's going to be a new person and they're going on a flight and holiday? So if we add all these numbers up, again, you're likely to calculate it, but we've got 18 there. Add another 12, that's 30, 39, 49, 58, 60, 70, 80, 90. So we've got 90 people booking on. That's the fraction. If you remember how we turn a fraction into a decimal, we divide the bottom number into the top number. So we've got 19 divided by 90. And that equals our decimal. That's what we want. If you wanted a percentage, we times that number by 100, and that equals our percentage. But it doesn't ask for that. So let's get our calculator open. If I can find it today, I've closed it. There we go. Calculator should be open on this screen. And again, if you weren't sure with your adding up, you could 100% add these up. There's not a problem by going back through and saying, oh, 18, yeah, 30, 39, 49, 58, 60, 70, 80, 90. You could put all them in your calculator, you still get to 90. Right, so I've got 19 divided by 90, 0.211. So the answer is 0.211. It doesn't say to 2 decimal places, but generally I would put it to 2 decimal places, because on your calculator there you've got 1 recurring, so you've got 1 forever. So 2-1, absolutely fine. That's 2 marks because you've identified the line it's on and then the number. Luigi sells milkshakes in different flavors. Customers, oh, I tried looking to customers, waiting to minutes, okay, 1 second. Let me just pause that. Somebody wants to join. Let me just quickly grab the calendar so I can send the invite. 1 second. What is happening with my calendar? It's not letting people join when it should. Copy link. No, that one. Sorry, be 1 second. I'm just literally going to send a link to that person. If I can find them. Right, let's see if I can find them. And we'll jump back into those questions in a second. Can't even find how to. There we go. Right, we should be able to now send this link. And then we'll get straight back into that question. Maybe later. Right, there we go. Okay, so that link's sent. Maybe the person will join, maybe they won't. Okay, so we were now in this question here. Luigi sells milkshakes in 3 different flavors. Customers can only order a combination of chocolate, strawberry, or vanilla. The Venn diagram shows a number of milkshakes and their flavors that were sold in one day: strawberry, vanilla, chocolate. What is the probability that the customer chosen at random ordered a milkshake that contains strawberry and vanilla? Give your answer as a decimal. So we've got all these customers. So we add them all up for the bottom number of our fraction. But the top number of our fraction, strawberry and vanilla. So as you can see, the Venn diagram, we've got strawberry and vanilla there. That's 5. And then we've got strawberry, vanilla, and chocolate. Couldn't think of what worse. Don't really like strawberry ice cream. Vanilla chocolate, absolutely, but strawberry, no. So we've got 8. There's a probability here of 8 ice creams that are chosen have got a mixture of strawberry and vanilla, with 3 of those have got chocolate as well, but that's fine because it's got strawberry. That's there for strawberry and vanilla. So we've got 8 there, add another one, 9, 16, 20, 22, 32. So as you can see here now, I'm going to double check, and we've got 8, and number 6, that's 14, that's 24, 24, 25, 32. So that's definitely right. Give your answer as a decimal. So we're going to go 8 divided by 32. If you're thinking already, oh, that's a fraction, 8 is 1/4. So if we're going to get 8 is 1/4, we know that a quarter is 0.25. We can check because it's a calculator paper. So we could just go 8 divided by 32. Oh, not 832, obviously. 8 divided by 32. We've got 0.25. So we can recognize that there as an equivalent fraction to 1/4, because 32 is 4 times bigger than 8. And that's that one there. Right, let's. Morning. Not sure what happened there. It happened yesterday. I don't know what the links. I don't know what's happening with the links in Atom. They're straight from my calendar. So I'm like, I don't know. We shall see.
Oh, okay.
But you're in. That's cool. There's not that many questions for probability. As I say, I'll go through these ones and maybe look at some areas that you've found that you're struggling with on an Atom maybe, but where I've just done that one. That's 2 marks as a decimal. There's only a couple left, but yeah, happy to go through other things. So Matt wants to cycle to his friend's house tomorrow. There is a 0.34 chance of it raining. What is the probability it does not rain tomorrow? So when we're talking about tomorrow, it's definitely going to happen. Definitely, because tomorrow's coming. So we've got a 0.34 chance of rain. It's not saying snow, foggy, cloudy. So the chance of it not raining is basically 0.66 of it not raining. It's just the opposite number that makes up to 100. Probabilities always have to equal 1, or as I look at it, it's been 100%. Tomorrow's definitely 100% going to happen. It's 34% chance of rain, so I've got 66% chance of it not raining. Give your answer as a fraction. Well, 66 over 100 is my starter fraction, because that's 66%. Can I make that smaller? Absolutely. I can shrink it. I can go divide them both by 2. 33 out of 50. So I divided both by 2. Going smaller than that, I'm thinking, well, that goes by 3. No, that doesn't, because that'd be 51. So it doesn't go by 3. It doesn't go by 2. 11. No. So that's as small as it gets. We can't shrink it anymore. So as a fraction, we've got 33 over 50. The chance of it not running tomorrow is, yeah, look outside today. It's definitely, no, don't know what it is today. It's just a bit grey and miserable. It's just weird. Not good. Marco holds an event to celebrate the results of some of his students. The table shows the number of students and the subjects they studied. Marco chooses one student at random. So all the students is our bottom number. What is the probability that students studied both biology and earth science? So we studied biology and earth science. It's this one here, look. So we know it's 12.
Yeah.
And then we add everybody up for the bottom number. So 12 add 7 is 19, add another 9 is 28, add another 1 is 32. So the probability is 12 out of 32. It's 1 mark. So we keep it exactly as we found it. If it's saying it's worth 2 marks, it'll probably say, oh yeah, give your answer as a decimal or as a percentage. But if it don't say anything, and it's only worth 1 mark, keep it in exactly how you found it, which is that. I think, oh, we've got a couple more, that's all right. And I think when it comes to probability questions, quite often they don't really give you more than 2 marks because they know it's a visual, you're looking at some numbers, there's not a lot of math to do, you're just pulling out the right numbers. Jessica looks at online reviews for the modal caravan she wants to buy. So modal, most common. I bet I've not got the right numbers here. Oh no, she finds that 545 online reviews for the caravan. 294 of these reviews rated the caravan as excellent. Oh, well, nice. Jessica reads one review at random. What is the probability that Jessica reads a review rated as excellent? Give your answer percentage, hence why it's worth 2 marks. So the fraction is 294, because that's how many excellent reviews there were, out of 545. Fraction, wicked. So with any fraction, we divide the top number by the bottom number to get our decimal. It doesn't matter what the 2 numbers are if it's a fraction, and if we want a percentage, we times our decimal by 100. And that's the same for any and many questions. You always, if you've got your fraction, people are scared of fractions, but fractions are absolutely underpin loads of other things. So if you can get your head around fractions aren't scary, it's just saying you've got a chunk of something that's bigger. So 294 divided by 545 equals that, multiplied by 100 equals 53.9, equals 53.9. You're going to get a point for that. Some people might even say it's 54 and you'll get a point. It doesn't matter. You've done your sum and you've shown your way around it. Yeah, fractions underpin a lot of things. Fractions shouldn't be scary. I think of them as pizzas. Fractions are pizzas, and that's how many pieces I'm chopping it into, and that's how many pieces I need of my pizza. I mean, chopping a pizza into 545 pieces would be difficult, and you'd probably get a slither. But think of it as being, you know, that's how you're making it into something you can visualize. A fraction is a pizza. Munya cares for 16 residents. The table shows the number of residents in different age groups and the level of care they require. What is the probability that one of those residents chosen at random is 85 or over and requires level 4? So all these are 85 or over. And then level 4 care. So we're choosing somebody at random. We're not just choosing 85s and over. It's one of the residents at random. So it's all the residents, but out of all those residents, we've got 5 that are 85 or over and need level 4 care. And then we need to add up all the number of care. So it says 16 residents there. So rather than add up these numbers and I'm going to get to 16, I'll trust the question that it says 16. And it's a percentage. We've got our fraction, so that's the easy part. We're going to go our fraction top divided by bottom, which gives us our decimal. And then our decimal times by 100 times by 100 equals our percentage. I don't know why I've written percentage straight away. Equals our percentage. And that's your answer. And that's why it's worth 2 marks. We're identifying what needs to be done, creating a fraction from it. Right, 5 divided by 16 equals 0.65 times by 100 equals what? 5, that didn't work. 5 divided by 16. Did I get an extra 0 in there somewhere? 5 divided by 6. So I'm thinking it's got to be over a quarter because 4 is a quarter. I'm thinking, what? How is it 6%? So now times by 100 right now. I must have typed in the wrong number before. So 31.25. That sounds
a bit better.
Yeah, that sounds like it's a go. Sometimes you just recognize the fraction. There was a question above where instantly you recognize an equivalent fraction, 8 out of 32. I'm like, right, that's a quarter because that number is 4 times bigger than that. So you don't really need to do 8 divided by 32, but it's calculator paper, so trust your brain and go for it. And that, out of the last 4 exam papers, that's all the probability questions. So it happens. So there's 1 in that one, 1 in that one, 2 in that one actually, 2 in that one, and 2 in the first one. So most recently there's been 2 probability questions in the last 3. And then the 4th oldest one, there's just been the 1. So it does happen every paper. But as you can see, they're marks that, I'm not saying they're throwaway marks, but they're questions that are very visual. You've got all the information in front of you. You're very rarely having to do something first before you've got the information. There's a table, it's telling you everything here. There's the math there. There's the table. There's the math there. So a Venn diagram, that one's probably not the most confusing, but Venn diagrams, it's just another way of presenting information. So you have all the information there. It's just you might have been tempted on the Venn diagram here to only put 5 because it asks you which milkshakes have strawberry and vanilla. Well, strawberry and vanilla, oh yeah, it's 5. But there's these 3 as well because they've got strawberry, vanilla, and chocolate. So that's probably where you might miss a mark on that one. But generally, probability questions happen every time. It's just low-level mark questions. But the ones that I think, and I don't want to say everybody should be getting them right because if you know them, you know them. But generally, the information's there. We're not having to create anything. It's the chance of plucking a red Skittle out of a packet. Think of it as being putting a whole bag of Skittles on the floor. And that's what you're doing. You're plucking something out of a bag. Right, let's stop sharing and then stop recording. Right, let's